Welcome to this video on how to train your Widrow-Hoff Adaline demonstrator. When you first activate the device, you are presented by this 4x4 Neo Trellis keypad, which represents the input pattern. The buttons on the keypad can be pressed, and they toggle between red and blue, like so. Each button represents either a +1 blue or a -1 red in the input vector, which is stored inside the Arduino, which is a central control unit and runs the Adaline algorithm as contained inside the box. There is also an RGB LCD which displays the output of the Adaline neuron, which has been passed through a sigmoid nonlinear function. Currently it displays sig = 0 as it has not been trained yet. There are also two buttons, blue and red, which allows us to train the Adaline to classify different patterns input on the keypad to either the positive class or the negative class. So positive class is blue, negative class is red. The output is also coloured according to the class of the output. So red would mean class negative and blue for positive class. When I press either of the buttons, the device invokes the least mean square algorithm, or LMS, and trains the Adaline neuron to classify the pattern into the respective positive or negative classes. It does this by using the error between the output on the screen and the desired class, and it adapts the internal weight vector, which is stored inside the Arduino, in a traditional way according to the LMS algorithm. In order to demonstrate the training process, we can enter any 4x4 pattern that we like on this pixel keypad. Bernie Widrow often used the letter T and J to demonstrate his device, so I'm going to do the same here. So I will enter a T pattern, like so, by pressing the buttons and toggling them to blue, and train it to belong to the positive class by pressing the blue button for about half a second or so. We can see that the adaptation is quite quick, even though it has actually some delays built into the algorithm to slow it down, so we can see the progress of the training process. So currently it says 0.8. And this number would indicate a strong positive classification. The screen has also gone blue to indicate that this T pattern now belongs to the positive class. I can now enter a J pattern. So the J pattern is quite similar to the T, and it has this long vertical, and that's deliberate to present a little bit of a challenge to the device. And I can now press the red button to train it to the negative class, and press that a little bit longer, and I've now got a number that's close to -0.8, which again shows a strong negative classification. Every time we invoke the training process, we're updating the internal weight vector, and this will affect any previously trained outputs. So I need to go back and check the T pattern still belongs to the positive class, and I'm happy to say that it does, although it's dropped in strength a little bit, so I'm going to reinforce that slightly by pressing the button a little bit more. Okay, I can go and check the J again to make sure it's still negative. It is still strongly negative. Happy with that. So it's now learned those two patterns, but we can extend the classifier to recognize extra patterns in the two classes. And this is also what Bernie Widrow did with his Adaline demonstrator. So he added translated versions of the T and J patterns. So in this case I can do the same here. So I can take the J pattern, and if we translate it just 1 pixel to the right, it would look like so. Okay, and I want that to belong to the negative class, so I'm going to press with the other J. So I'm going to press the negative button. That's good enough. And I'm also going to input a translated T pattern. So that would look like so. Okay, that T pattern is 1 pixel translated to the left. It's currently positive but not that strong. I'm going to increase that a little bit. So now that I've trained both, I need to go back and check that all the other patterns are still correctly classified. So let's see. I'm going to go back and check the original T pattern like so. That's still strongly positive, happy with that. I'm going to go and check the J pattern, that this belongs to negative. It is still reasonably strongly negative. I can go and put the translated J pattern, that's also negative. So we can see that both J's are negative and both T's are positive classes. So we've effectively trained our Adaline to recognize two patterns in two classes. Hopefully you can see how you could train any unique patterns to be classified into positive or negative classes using this Adaline demonstrator device. Thanks for watching the video created in support of our forthcoming publication in the IEEE International Conference on Acoustics, Speech and Signal Processing 2024.